Hi, this is Dave Beliveau from New Wave Technologies, and welcome to this LightWave feature tutorial using blobs. The features described in this tutorial are available in current LightWave Client GA releases and are available in LightWave Server 1.1 beta releases, with GA release scheduled for late 2020. And these features are described in our online documentation for both client and server in the Developer Guide section under Advanced Topics, using blobs. Okay, so let's start with the obvious question. What's a blob? Well, BLOB is an acronym for Binary Large Object, and Binary Large Object is a term originally used in the database software world to describe a field that stores binary data. And that means any binary data. It could be the contents of a file, an image, an encrypted message, a PDF, spreadsheet, anything. Now, as you may know, LightWave Client and LightWave Server are able to translate structured IPM data to and from JSON and XML and transfer that data using HTTP protocol in a RESTful way. But there are cases where you might not want to use those translation services. For example, you might want to simply transfer something like an image or text or PDF file to or from a web service. You still want LightWave to handle the hard stuff like network I/O, HTTP, and TLS protocols, authentication, all that stuff, but you want your data transferred as is, and that's where you can use blobs. LightWave Client and LightWave Server support two types of blobs, IPM blobs and file blobs. IPM blobs are used if the blob data that you want transferred fits neatly within the 2 megabyte Guardian interprocess message size limit. You have to be a bit careful there because typically in server applications and always in client applications there is some header overhead in the IPM, so the available blob size is typically less than the full 2 megabytes. When IPM blobs can't be used because the data size is too large to fit in 2 megabytes, you can use file blobs. With file blobs, the blob data is stored in an inscribe file, which allows the data to be pretty much any length within reason. LightWave will transfer the blob data by reading from or writing to the inscribe file, and the name of the file is provided in the application request or response IPM. So for an outbound blob operation, the application would include the name of the file containing the blob data in the IPM, and LightWave will read the file and write the contents of that file to the outgoing HTTP body. For an inbound file blob operation, the LightWave process writes the incoming HTTP body content to an inscribe file that it creates and provides the name of that file in the IPM. Okay, now that you know what a blob is, let's take a look at how you can use blobs with LightWave Client. Here's the LightWave Client API editor, and under data mapping for the operation request, we've mapped the HTTP request body to the content type blob. The data source is IPM, and we've set the maximum length of our blob data field to roughly 2 megabytes. When we generate the DDL for this operation, the output DDL contains the blob field with the size we specified and an additional blob size field. When the application sends the blob data in the request, the blob size field should be set with the actual size of the data in the blob field. For a response containing a blob, the mapping is similar, and these same two fields will be contained in the DDL. When the response is received, LightWave Client will set the actual size of the data that was in the HTTP request body as the value of the blob size field. Here's an example of defining a file blob. It's similar to IPM blob. We just set the data source to file instead of IPM, and we don't need to specify a length. When the DDL is generated for this operation, instead of a blob and blob size field, it contains a blob file name field. On a request, the application would supply the name of an input file that contains the data, and the client process writes the contents of that file to the outbound HTTP body. On a response, the LightWave Client process will read the incoming HTTP body and write it to a new file, and sets the name of that file in the blob file name field. And this is a good time to mention that when you're sending blob files, the LightWave client process needs to have read access to the blob files. And when LightWave client is receiving blob files, you can use the blob file startup option to specify the file creation options for the output blob files, such as location, the file name prefix, owner, security string, and extent sizes. Also note that it's the responsibility of the application to manage any blob files. The LightWave client process reads and creates blob files, but never deletes or archives them. So if your application uses blob files, it's also responsible for managing the final disposition of those files. All right, let's take a look at how to use blobs in LightWave Server. Let's start with Blob Fields. Here's some DDL for an IPM that contains a blob field. We define the blob field as a large character string, and we're using a LightWave attribute to specify that the blob size field will contain the size of the data that's in the blob field. Once we import that dictionary or create the dictionary from the DDL and import it into LightWave Server, in the dictionary binary view, we've got our blob field, and it is a very large string, and we have our sizes referenced to the blob size field. We can now use it in our API definition. We select the dictionary containing the blob IPM. In the field mapping, enter the blob field from the IPM and set the source to HTTP request body to blob field. And that's it. This will cause LightWave Server to copy the incoming HTTP request body to the blob field, and then it will set the size of the body in the blob size field. If we're defining a response, you select the dictionary, enter the blob field from the IPM, and set the target to HTTP request body from blob field. This will cause LightWave Server to copy the contents of the blob field to the HTTP response body, using the value in blob size to indicate the size of the data that's in the field. Defining an API operation with a blob file is very similar. Simply create an IPM with a character field of sufficient length to contain the inscribed file name. In this case, it's 256 bytes, and that is more than sufficient. And the rest of the definition steps are essentially the same as those for a blob field. In the API definition, select the dictionary, enter the blob file name field, and set the source type to HTTP request body to blob file. This will cause LightWave Server to copy the inbound HTTP request body to a new inscribe file and supply the name of the file in the blob file name field. Now, where is this file created? Well, just like LightWave Client, you can use the blob file startup option to indicate the location and attributes of any blob files that are created. Or, for each operation, you can override the server defaults with blob file creation attributes specific to that operation. So if you want blob files from one operation to go in one subvol, and those from another operation to go in another subvol, maybe each with different creation attributes, you can do that. And remember, just like with Client, it's up to the application to clean up any blob files that are created by LightWave Server when the application is done processing them. If we're defining a response, you select the dictionary, enter the blob file name field from the IPM, and set the target to HTTP response body from blob file. This will cause LightWave Server to copy the contents of the inscribed file named in the blob file name field to the outbound HTTP response body. And here's some good news. For responses, there is an option to automatically clean up a blob file when the response has been returned to the client. This allows an application to create a blob file on the fly, hand it off to LightWave Server to send back to the client, and not have to be concerned with the final disposition of the file. LightWave Server will purge the file when the response to the client is completed. And there it is, everything you need to know about using blobs in LightWave Client and LightWave Server. Again, these features are documented in our online documentation at docs.newwavetech.com. Just select your product and navigate to Developer Guide, Advanced Topics, Using Blobs. And if you have any questions or comments about this or any other product feature, head over to our support website and open a case, or just send an email to support@newwavetech.com. Thanks for watching, and keep an eye on our YouTube channel for new product tutorials and demos.